Alrighty, let's talk about line of best fit by eye. So considering this scatter plot below, let's try and place a line of best fit. So how is the best way of actually going through and creating a line of best fit? Well, in this case, the best thing to do is to try to just draw a line that goes through the data as cleanly as possible. I might even get a straight line. Now you'll notice I tried to draw a line in such a way that I'm as close to as many points as possible. So I didn't want to draw a line that was really off to one side or another, because then you end up with points that are quite far away from the line. So you really want to be looking at trying to get as straight a line as possible and as clear as possible. So then what do we need to do? Once we've placed it, we need to be able to calculate the A and B values, right? If I want to calculate a line of best fit, it's A plus BX when we're on the calculator, or if we're on the formula sheet, it's A plus BX as well. Okay, so we need to be able to calculate it. Well, what do we need to calculate the line? Well, we need exactly two pieces of information. 2 points. Any 2 points is fine. So the best thing to do is to find 2 points. Now, I want to choose points that are on the line, not random points. So this point is no good for me because it's not on the line. This point's also no good because it's not on the line. I need 2 points that are on the line. So let's find, say, this point here. That's on the line. So that would be halfway between 40 and 60, so that'd be 50 on the x-axis, and on the y-axis it'd be 25. Let's find another point. Let's look at this one here. Halfway between 20 and 40, that'd be 30, and 15 high. So 30, 50, and 50, 25. So B, since it's the gradient, M, is just y2 take y1, the rise, over x2 take x1. So what are my y's? 25 and 15, so 25 minus 15, all over 50 minus 30. And just make sure your partner points are next to each other. 50 goes with 25 and 30 goes with 15. Alrighty. So that means we get 10 divided by 20, or 0.5 is my B value. So then in order to find my A value, I just need to choose one of the points and sub it in. So I've got my gradient. So my gradient B is equal to 0.5. So for part C, to determine the y-intercepts, I need to use my gradient. So my equation is currently A plus 0.5x. Right? I'm just using my B value there. So now I need to choose a point to sub in. So which is my favorite point, 30, 15 or 50, 25? I like 30, 15. Let's do 30, 15. So sub in x and y equal to 30, 15. So where I see a y, I'm going to replace it with 15. Where I see an x, I'm going to replace it with a 30. So 0.5 times 30. Now 0.5 times 30 happens to be 15. Take 15 from both sides, and we get our A value just like that. 0 is equal to A. So that's my y-intercept. A is equal to 0. Therefore, my equation is equal to y equals 0 plus 0.5x, or another way of writing that is just 0.5x. Your choice. Okay, what's another strategy? Well, I've got a calculator, and my calculator can calculate A and B. And calculators can calculate A and B if it's given 2 points. So instead of doing all of this to find A and B, on our calculators we could just set up a table, and we only need to put in 2 points. So x and y, 50, 25 is my first point, 30, 15. And if you put those into the calculator, you'll get an A value of 0 and a B value of 0.5, and if you work out R2, of 1, because between 2 points there's only one line that goes through it, and it goes through it perfectly. In this case it's positive as well because it's going up. B is positive. So those are just two different strategies. You could do the algebra if you remember how to find a line, but if you've forgotten how to find a line, it's no trouble. Just type your data into stat mode and use regression to get these up. See you in the next one. Goodbye.